Hey everyone, Cameron here, telling you about the best tools that will help enable open science and better and more transparent workflows. Today we're going to be talking about Git, which is a version control system. And what I want you to do is imagine that you're working on a research paper, or maybe you're analyzing some complex data, and you suddenly need to go back to an earlier version of your work. Or maybe you're collaborating with colleagues and everyone's changes need to fit together without conflicting with one another, and handling this manually is a real challenge. The problem that we tend to get into with this type of either collaborative workflow or a spot where we need to go back in time is that often we don't keep track of our documents. And what this means is if I'm working on a paper with my advisor, I have a tendency to, well, maybe write up a draft or make edits to an existing draft and then send them an email. And then in that email, they maybe add some more comments, make some more revisions, and they send me back a new document. And this type of workflow is a disaster when it comes to keeping track of what changed in what version. And so if you ever need to go back, digging through your emails is no way to handle a changing and living document. So today we're going to be talking about Git, which is a tool that will help you keep track of every version of your work, making it easy to revisit old changes, fix mistakes, and explore new ideas. It also lets you work seamlessly with others by tracking who made which changes and merging everyone's contributions smoothly. Well, today we will not be talking about collaborating with Git or even talk about GitHub. We will simply talk about how you can use Git on your own personal computer to do your own personal work. So in this session, I will be demonstrating everything from the command line, but I do understand that if you are new to the command line, or maybe you just prefer working from a graphical user interface for Git, then do not worry. The concepts and commands that we are going to cover will give you a solid understanding of how version control works, which will make using any Git tool easier. So let's go ahead and jump into our introduction to Git. Now, before I start talking about the nouns and the verbs or commands, the two things that we'll be talking about in today's video, I do want to mention one thing that we will not be talking about. For my more advanced users or anyone who is somewhat familiar with Git, we will not be talking about branches. Instead, we are going to focus on some very basic nouns, and we're going to focus on some very basic verbs. So our basic nouns are just two things. I want you to keep in mind that whenever I say repository, all you need to do is think of a computer or a folder that is on my computer that's currently being monitored by Git, or as we say, under version control. It is nothing fancier than that. It is just a folder on my computer, and there's a Git folder within that. Now, we'll also be using the term commit. And whenever I say commit in this video, I want you to think a commit is a, quote, snapshot of a given repository. And really, when I say snapshot, it's just a copy. So a commit is almost like a backup of all of the files that exist under your repository or under your folder. And so today, we're going to be talking about just a couple of things that we will do with version control or with Git. The first thing that we're going to talk about is initializing a Git repository. Then I'll show you how to check the status, how to add things and make new commits or new snapshots. And then finally, we'll talk about how you can look over a timeline of all your snapshots and go back to a specific snapshot if you need it. Now, we'll be using this slide as reference, but I want to show you a demonstration that I've prepared for you all. In this brief demonstration, we're going to be using my .counter repository. And right now, it's not actually a repository just yet. It is simply a folder with files in it. On my screen, you can see the files that exist within this folder. I have one Python script or .py file. I have a folder of images, but there's only one image in it, and it's called dots.jpg. And I have a requirements.txt file. Now, we won't talk much about the requirements.txt file. This is primarily if you want to have a somewhat reproducible environment when working with Python. There are better tools or better standards than this nowadays, but I want you to focus on the .counter.py file as well as the dots.jpg. Let's take a quick look at the dots.jpg. In this file, it is simply an image, and I have a bunch of colored dots. These colored dots are red, green, and yellow. And you can imagine that as part of maybe my research process or a project that I'm working on, I have been tasked with counting these dots and counting them by color. So I want to know how many red dots are in here, how many green dots are in here, and how many yellow dots are in here. Now, I could absolutely do this by hand, but it's going to be very tedious. And you can think it will be tedious if I have more than just one image. And so what I have done here is I have simply created a small program called .counter.py that will help me automate this process. And I promise you, .counter.py is not a very difficult or long program. It's about 70 lines of code, and I'm sure this is something that you all might come up with. But here you can even see I'm very explicitly counting, right, red, green, and yellow dots here. So let's take a look at what this program does. I'll go ahead and call the .counter program from my command line here, and I'm going to pass it the dots.jpg. When I do this, I get some nice output, and this output tells me that the number of red circles detected was 10, the number of green circles detected was 39, and the number of yellow circles detected was 31. And I even have a flag. If you don't believe me, I even have a flag to show a rendered image that has what each dot was classified as. And so here you see the original image in the top left, all of the red dots denoted with a small black square in the center and a small black circled outline for each of the red dots, the same thing for the green dots, and the same thing for the yellow dots. So we're trusting that these counts line up with reality, and we'll trust that this program works. So where does Git tend to fall into this workflow? Well, as part of my work, I may decide that those titles that you saw in the .counter charts, they were all center aligned above the graph. And I don't love center aligned titles. So what I'm going to do is I'm going to pass lock equals left. I want to left align those titles. But maybe while I'm working partway through, all of a sudden my editor crashes. And I don't remember where I left off specifically, because in a real world setting, this could have happened not just after changing 2 lines, but after changing hundreds of lines. And you're thinking, oh, maybe this idea that I'm trying isn't working, or I don't know how to recover. I really just wish I could go back to a version of the code that worked. Because you'll see here, when I try to run this code, I get a syntax error. Now, this syntax error is quite easy for us to solve. But if this problem was more complex, you can think I would probably spend a couple of days or at least a few hours just trying to get my code back to a state where it was working. And I so wish I could go back to about 2 minutes ago when I had the working version of the script. So I'll go ahead and reopen this file here. I'm going to manually put my code back into a working state, removing all of the lock equals left arguments. And I'll show you that this code works. Now that we are in a best known or a working state, let's use Git to clean up this type of workflow. So the first thing I'm going to do is I want this repository to be under version control. And how I do that, going back to our slide here, is I need to first initialize the repository. So I'm going to call git init here to begin tracking this folder, my .counter folder, with version control. So I'll just go ahead and use git init. And you can see that Git has told me that it has initialized a repository. And what I can do now is I can use my next verb. I can check my Git status. And remember that our Git status is just saying, well, do I have any pending changes that are not part of a snapshot or part of a commit? And you can see that Git is telling me I have no commits. There are no snapshots. I haven't made any just yet. In fact, there are 3 files and none of them are actually yet entered into version control. So Git is telling me that I have 3 brand new files that are not part of any snapshot or any commit. And so a very common thing is if you have code that already exists and you want to add it to a Git repository, you have to initialize that repository and then you need to add all of those things into version control manually. And we'll do that using our add and our commit verbs. So I'll go ahead and show you how that works. The first thing I want to do is I want to git add all of those files. Now I can use a dot here from my command line to say add all of the files under my current working directory and all of the subfolders, and I can do that recursively. Or I can type out the names of the files manually as well. So I can say git add dot counter. I can also say add the images.jpg, as well as the requirements.txt. Either is up to you. Sometimes a little bit more specificity helps you make sure that you're not accidentally snapshotting things that shouldn't be there. So I'll go ahead and run this git add command. Now remember that git add is our synonym for in my next snapshot, right? I haven't taken a snapshot just yet, but in my next one, I want to incorporate these files. And those are the 3 files that you just saw me type out manually. Now that I have these files added, they're entered into what's called my staging area. My staging area is simply a space where you're going to outline all of the files that should be included in your next snapshot. Now, if you want to remove or restore a file, you can use the command here above, git rm cache, to unstage or to remove this right from the working area or the staging area. But I don't want to remove anything from the staging area just yet. I do want to commit this so that I have my very first snapshot of this code here. So I'll go ahead and use my git commit verb, and I'll use the -m flag because I want to pass a message. Messages are great for when you need to go back in history and search for something specific. This is a semantic almost tagging system, or I should say a semantic meaning that you're going to provide with every single snapshot. So in this snapshot, since this is the original or the first version of all of these files, I might want to say something like this: add original version of repository. And this is just going to be my first commit. You can think that the first commit isn't going to have a bunch of semantic meaning because it's hard to encapsulate all the work you've done thus far, but we will have the ability to add even more meaning with our next commit and our subsequent commit after that. So let's go ahead and take another glance at our previous workflow. The first thing that I did, remember, was I went into my .counter.py and I said, you know, those center align titles, those aren't good. I want to left align them. So I'm going to pass this lock equals left here, and I'm going to pass lock equals left, and then all of a sudden, just like last time, my editor crashed. It crashed somewhere while I was writing. I don't know where I left off. It's going to be hard for me to debug or unwind this thread. But what I can do is I can do a couple of things. First, I can check my git status. Remember, git status is our short or a synonym for, do I have any changes that are not part of a snapshot? And Git is telling me that yes, I do have a change. There's a change inside of the .counter.py file, and it's not yet part of a snapshot. And so what I can do is, if I want to go back to my previous known working version, or my version as of my last snapshot, remember that was my first snapshot, then I can use the git restore command. And very quickly, I'll show you this script is absolutely broken. And what I can do here is I can take that file and I can revert it back to its previous version so it's aligned with my most recent snapshot here. So I'll go ahead and restore that file, and my program will now run, but you will notice that my titles are still center aligned here. This is because, right, we have gone back in time to revert this file, or I should say, restore this file to a previous version. So let's go ahead and maybe we'll actually successfully, this time, left align these titles. So I'll go ahead and change it there, and I will fully change it here. I'll rerun this program just to make sure that these titles are now left aligned above these charts, and they are, which is great to me. So what I will do now is I can check my Git status. In my Git status, Git is telling me that I have made a modification or change.counter.py. And since this change is semantically complete, meaning it's in a working state and I'm happy with the result, I can go ahead and add this file to version control. So I'll go ahead and use git add.counter and do a git commit, passing a nice message to say left aligned titles of charts. And this is my semantic message to future me to say, what did I change from this snapshot compared to my previous snapshot? Well, the titles of my charts are now left aligned. And so we have successfully saved that snapshot into our version control. But how do we go about maybe checking all of the snapshots that we have available with all of their messages, as well as the timestamps and any other associated metadata? This is the job of git log. So we're going to go ahead and check my git log, and you can see right here that in my git log, I have 2 snapshots. Whenever you see yellow text with commits or just text with commit, that is a snapshot. And so since I have 2 lines that have this similar commit with a randomly generated numbers and letters, or seemingly random, I'll say, you know that those are separate commits. Historically, you have the most recent commit on top, and you have the least recent commit on bottom. And since we only have 2, you can see that in this commit, the author was me, the date is today's date, and my message, which I left for myself just so I would know what was in this snapshot, well, I just added the original version of the repository. Not too meaningful. But in my more recent commit, the second commit that I made, we have left aligned titles of my charts. So I know that in this commit, I have actually done some meaningful unit of work, and I'm in a known working state, hopefully. What I can then do is if I have more commits, even with just 2, with this git log and with our git checkout mechanism, which will be our very last verb, I can go to any of these specific snapshots here. So if I want to not go to my version where I have left aligned titles, such as this one, as you see in this output here, and I want to go back to the version that was before it, I can always go through my commits. I can grab this unique identifier here, and so I'll just go ahead and copy that, and then I'll use my very last verb, that is git checkout. And I can just paste that string, that text of random letters and numbers, and I can go back in time. Now, Git does give me one warning here, and this is because typically when you go back in time using Git, you should not make any changes here. And the reason that you shouldn't make any changes is that with Git as our version control system, we can do more than just make additions. We can make deletions. We do not need to undo changes and work from there. We simply need to keep moving forward. So going back in time using this git checkout mechanism to go back to a previous commit or previous snapshot is great for just looking around. And then when you are all done looking around, you should use the git switch command as Git has told me here. So I can look around, I can take a look at any of these files, I can run my code, and you can see that since I've gone back in time, my titles are center aligned. Now, when I'm done just looking around, I can always use that git switch command with the dash, and you can see that Git has switched me back to my most recent working version. And I can prove it to you because my titles are left aligned, which is my most recent working version. But like I was saying earlier, Git is not just made for adding lines of text or changing lines of text. Git also tracks things like removing files. And because of this, I can confidently remove any of these files because I know that using my git restore command, I can always go back to the previous most recent commit. So I'm actually going to fully remove .counter.py. Or maybe I'm going to remove my entire images folder. I'll start with just removing .counter.py. Notice that that file is completely gone. I don't see it anymore. But according to Git, if I check my Git status, we see that this file has not been modified, but instead it has been deleted. I think accidentally deleting files is something that we all do. And this just by itself should be reason enough for you to start picking up an effective version control system. And so what I would do if I accidentally deleted my main Python script, thankfully Git comes into the rescue because this is just another change. It's the same type of change or a similar change to our modification that we saw earlier. And so if I want to go back to a known working version, I can use my git restore to do so. And when I do that, you can see that my .counter.py file has returned. And that covers all of the very basic nouns and verbs that we had in store for you today. So hopefully you feel some more confidence in using Git either from the command line or from a graphical user interface. Before we wrap up though, I do want to share with you a couple of graphical user interfaces that are great to use. But with that all said, we have seen all of our nouns, our repositories and commits, and demystified a lot of their meanings, and we've seen some of the most basic Git verbs and commands. Like I said though, before we wrap up, you can grab a Git GUI client. There are so many. I think a very popular one is going to be GitHub Desktop. This integrates not just Git workflow for your local machine, but it also lets you integrate easily with GitHub, which is something I'll show you how to do from the terminal in another video. But with that said, the other GUI clients that are very popular are ones that integrate with your code editors. So a very popular choice is going to be using the Git integration inside of Visual Studio Code, or maybe even using a Git integration inside of your Jupyter Lab if you use Jupyter Notebooks. But with that all being said, that's all the time that we have for today. So I want to thank you all for tuning in and hope to catch you at another video sometime real soon. Thanks, everyone.